Hello friends and welcome at my channel. Today I would like to explain the idea behind the inverse function of the sine, so the arcosine, and at the end of the video we will derive also the formula for its derivative. Okay, so I hope you remember how the sine looks like, but maybe you remember at the same time that this is the function which repeats itself infinitely many times, right? So the thing is, we cannot inverse this function easily because it repeats everywhere. So what we have to do now, we have to find an interval where this function is bijective, which means it's injective and surjective, or if I simplify the idea, where the function never repeats and where we get all the values from the range. And if you remember, the sine curve is the curve which goes through the origin, and it does something like that. So we are at pi divided by 2 at 1, at minus pi divided by 2 we are symmetric considering the origin at minus 1, so this is the value minus 1, this is the value plus 1, so far so good, and 0, 0. All right, so if we define f, it goes from minus pi divided by 2 to pi divided by 2, from this interval to minus 1, 1, as you see it here, minus 1. Oh, bad. Don't want to leave it this way, sorry. Minus 1, 1. And the inverse function obviously must do the same, but in the different order. So from minus 1, 1 onto minus pi divided by 2 to pi divided by 2. And if you remember from the previous videos also, we have to be symmetric considering the identity function. So somehow maybe we will squeeze it later on. Pi divided by 2 is approximately 1.56 or something. So we're here at 1 somewhere, and or maybe even closer to the origin here maybe, and so this is 1, 1. So the inverse function minus 1, minus 1. So let me try to. So this is the line we have, and now you see the inverse function. You remember sine of x is behaving as approximately or comparably to x, very close to x at 0. So you see this is exactly the same stuff we see here in the picture. And what will happen if we are looking at the inverse values? Well, for example, you see arcus sine of 1 is obviously pi divided by 2. Pi divided by 2 is more than 1, so we are somewhere here. All right, so maybe not too far away, like this. And at minus 1, we're somewhere here. So this is how it works. And we go through the origin, of course, and we have to be symmetric considering the graph of the identity function of the black line. So let me try to put it here, something like that. Okay, so this is then arcus sine, and you see we have nowhere a kink, we have no problems with the slope, so it seems to be differentiable. And let us try to do this. So we know that the derivative of f of x equals to sine of x. The derivative of this guy is just the cosine, all right? So what would be, we would like to compute the derivative, so the inverse is Arcsin. By the way, the name Arcsin, if we're taking sine, we're having degrees sometimes, and we're mapping it onto quotients, right? Onto values between -1 and 1. But we can also take, instead of degrees, we can take also the lengths of arcs, the lengths of curves. And we are measuring them in radians. So what the Arcsin is actually doing, we're taking the quotients and we're mapping them back on the lengths of arcs. This is where the name is coming from. Okay, so the derivative of the inverse function, if you remember the formula that we derived, otherwise you have here the link, is equal to 1 divided over f prime of, is that the formula? No, I have to remember. Yeah, that's the formula. Okay, this is what I've done. Yeah, I think it is. All right, so arc sine prime at sine of x is equal to 1 divided over cosine of x. And you see the problem we have here is that this is the sine and this is the cosine, and I cannot substitute it the way I was doing with e in the logarithm. So what we do here, we are remembering the Pythagorean formula for trigonometry. Cosine squared plus sine squared is giving you 1. That means cosine itself is, well, plus minus, forget about minus, let's just take plus here, doesn't matter, sine squared of alpha. So I'll substitute this cosine value. Okay, so I have arcosine prime of sine of x is just equal to 1 divided over square root out of 1 minus sine squared of x. Well, that's nice, because if you substitute it by a, we got the formula. Or maybe a is not good with arcosine. Let's substitute it by z. So arcos sine prime of z would be just 1 divided over square root of 1 minus z squared. Isn't that nice? And of course we have to say z is not further than 1, and so z, absolute value, cannot be over 1, or even strictly must be less than 1, right? Otherwise we'll be dividing by 0. So that's the story. All right, thanks for watching. I hope it was clear. See you in the next video. Bye bye.